So for today we'll deal with matrices and determinants. Definition, please. Definition. A matrix is the array of numbers in rows and columns encased by a bracket. The array of numbers in rows and columns encased by a bracket. By a bracket. A bracket. You can add a round bracket if you want to, right? Encased by a round bracket if you want to. Alright, let's proceed. For any given matrix, the horizontal array of numbers is called the rows, R-O-W-S. For any given matrix, the horizontal array of numbers, I say arrangement of numbers, is called the row, R-O-W. While the vertical arrangement of numbers is called the column. Don't forget, please. Horizontal arrangement is called rows. Vertical arrangement is called column. That's it. Next up is dimension of a matrix. Dimension of a matrix. The dimension of any matrix is expressed as this. The dimension of any matrix is expressed as M. Please, this is called M by N, not M times N, please, right? Which one is called M by N. Where N is equal to the number of rows and N is equal to the number of columns. Right. M is called number of rows, N is called number of columns. That's N. N is equal to number of columns. Example. Identify the dimension of the following matrices. Example. Identify the dimension of the following matrices. Example, identify the dimension of the following matrices. So look up. We need the idea of dimension because dimension will help us to do the algebra of matrix, right? The dimension of the matrix will help us to do the algebra of matrix. So you have to have a good concept of what the dimension of the matrix is first before you do the algebra. Alright, if I'm asked to find the dimension of this matrix, what do? We said you arrange the dimension in this form. M is called by, not times. M by N. What's M? Number of rows. What's N? Number of columns. So I come to this matrix here. Count rows. What's a row? We said a row is what there? The horizontal array of numbers. So I'll come here now. I'll count them horizontally. If I count horizontally now for A, I have this first horizontal one. That's row 1. This becomes row 1, my first horizontal there. This one here, I have on there, row 2. So it has 2 rows. Count your column. What's column? The vertical array of numbers. So I'm taking this vertically. So I'm having this as what there? C1, my first column. Having this here as C2, my second column. Having this as what again there? C3, my third column. What's not the dimension? M by N. Number of rows by number of columns. How many rows here? 2 rows. Becomes 2 by, how many columns here? 3. Becomes of there a 2 by 3 matrix. That's it. That's easy. Come to this thing. What's the dimension here? Huh? Count columns. 1, 2. The 2 by 2 matrix. That is it. Come to this one here. How many? What's the dimension here? Please, rows by column. How many? Good. 3. 1, 2, 3. Column. 1, 2, 3, 4. So 3 by 4 matrix. Please copy that. Alright, so column, rows by column. That's all. No big deal. Rows by column. Alright, let's do addition and subtraction. It's actually called what do you call it, algebra, right? What about algebra? There are 4 basic algebraic steps: addition, subtraction, multiplication, what in there, and division. For matrix at this level, we'll deal with just 3 things. That involves addition, subtraction, and what? Multiplication. You don't really do matrix division. At least look at this level here. Don't do that. Right. So let's start with addition, please. Take down. 2 or more matrices. Take down. 2 or more matrices can only add or subtract if they are of the same dimension. That's all. 2 or more matrices can only add or subtract if they are of the same dimension. And that's why I said really because of the word there, dimension. That means you can give me 2 matrices there. Before you add it, you say do matrix A plus matrix B. Before you add it, you do what there? Check the dimension. If it's not the same, you cannot add. If it's the same, yes, you can add or subtract. Example, please. Example. Evaluate 2, 3, 1 minus 1, 4, 2 plus 1, 0, 9, 6, 2, 3. Alright. Evaluate this. Example. Evaluate this. So your first task is to look at this list. They say that if you say you should evaluate this, look at the sign there. What's the sign there? Plus. So I have to add them. Question, can they add? Yes or no? Can they add yes or no? Why do you think they can add? Same dimension. Look at this. What's dimension here? 1, 2. Column 1, 2, 3. Look up for there. 2 by 3. This one here. 2 by 3. 2 by 3. 2 by 3. Same dimension. You can add. When it comes to adding matrices, what do? Just add corresponding positions. That's all. Alright? I'll take this and this. So it becomes 2 plus 1, that's 3. 3 plus 0, that's 3. 1 plus 9, that's 10. Minus 1 plus 6, that's what there? 5. 4 plus 2, 6. 2 plus 3, 5. That's all. That's it. Just add corresponding positions. That's all. Alright, let's imagine you are subtracting. What if these were subtracting? What was subtracting? The case will now be, can they subtract first? Obviously yes. Why? Same dimension. Of course, 2 minus 1 is 1. 3 minus 0, 3. 1 minus 9, minus 8. Minus 1 minus 6, minus 7. 4 minus 2, 2. 2 minus 3, minus 1. That's all. That's all. Alright, example 3. Evaluate this plus this, please. What's your answer? Work on it. What's your answer? Just add them. What do you have? You have what? 5, 4. What do you have? Yeah, you got what? No. What do you get? What do you get? What's your answer? Check. What's your answer? 4 what? 4, 1. Huh? Yeah. Good. Huh? What are you adding for crying out loud? We just said they cannot add. Why? They are not of the same dimension. So where we get your 4 from? Look at this. What's the dimension here? 2 by 3. Abi? Yeah? 2 rows. 1, 2. How many columns there? So you cannot add. This is 2 by 3 matrix. This is what here? A 3 by 3 matrix. They are not of the same dimension. So they cannot add. There's no answer to this. There's not, or you can say no answer. No answer. Alright. Example please. Example. If A is equal to 1, 4, 3, 2, 5, 7, comma, B is equal to minus 1, 6, 0, 13, 12, 11, and C is equal to 1 minus 1, 0, 6 minus 8, 9. Evaluate number 1, 2A plus B. Number 2, 2A plus 3B minus C. Number 3, A minus B plus 2C. Let's play with this, okay? This one you can get other ones. Just get the concept. So let's play with this thing. If I have a case like this, number 1, solution. Number 1, I'm asked to evaluate 2A plus B. What do you get? When I have 2A, what does 2A mean? 2 times A, Abi? Alright, so this now becomes equal to 2 into A. What's A there? 1, 4, 3. Next up. 2, 5, 7. Next up. So that's alright. 1, 4, 3, 5, 7. Plus what's B? Minus 1, 6, 0, 13, 12, 11. Alright. So your first task will be work with this one's first. Right, work with this one's first. So I'll now have 1 times 2, or 2 times 1, 2. I'm not adding, I'm multiplying. Right. 2 times 4, 8. 2 times 3, 6. 2 times 2, 4. 2 times 5, 10. 2 times 7, 14. This one here, plus into this, minus 1, 6, 0, 13, 12, 11. So I have this. Alright, so add them up now. I'm having 2 plus minus 1. Plus minus is minus. 2 minus 1 gives you 1. 8 plus 6, that gives you 14. 6 plus 7, that gives you 6. 4 plus 13, that gives you 17. 10 plus 12, that gives you 22. 14 plus 11, that gives you 25. So it's this equation. So when they say 2A plus B, multiply A by what there? 2. Add it to B. That's all. That's all. Alright, let's try 2A plus 3B minus C. This is now equal to 2A means 2 is multiplying what there? A. So we're having 2 into what's A there? 1, 4, 3, 2, 5, 7 plus 3 into B. B there is what there? Minus 1, 6, 0, 13, 12, 11. Next up, minus C. What's it there? 1 minus 1, 0. Next up, 6 minus 8. Now, so I have this. Multiply this. So 2 multiplies all of this. 3 multiplies all of this. So now I have equal to 2 times 1 is 2. 2 times 4 is 8. 2 times 3 6. 2 times 2 4. 2 and 5 10. 2 and 7 14. Plus, use 3 to multiply this. 3 to minus 1 is minus 3. 3 times 6 is 18. 3 times 0 is 0. 3 times 13 is 39. 3 times 12 is 36. 3 times 11 is 33. This minus into bracket 1 minus 1 0. 6 minus 8 9. So I have this. Alright. So at this point now, you can take them in 2 or you can take them 3 at once. But for simplification purposes, let's take them in 2. Right? What do I mean? Take the addition first. So it becomes 2 plus minus 3. Plus minus is minus. 2 minus 3 is minus 1. 8 plus 18 is 26. 6 plus 0 is 6. 4 plus 39 is 43. 10 plus 36 is 46. 14 plus 3 is 47. I have this. Next up, this one now, that's minus, you can see here, into this bracket here, that's 1 minus 1, 0, 6 minus 8, 9, so I have it. Alright, so work this out. This is now equal to minus 1 minus 1, that gives you minus 2. 26 minus minus 1. Minus minus is plus. 26 plus 1 gives you what there? 27. Okay? 6 minus 0 is 6. 43 minus 6. What do you get there? Huh? 37. 46 minus minus 8. Of course. Minus 1 gives you what there? Plus. Alright, so 46 plus 8 is what there? 84. 47 minus 9 is what there? 38. So this becomes my answer. Any question, please? Any question? So see why I solve this, right? Use 2 to multiply A plus use 3 to multiply B minus the new number here. Let's repeat C. Use 2 to expand this, you have this, plus 3 into all of this, you have this, minus this one down. Add all these 2 first. You get this one here, then minus this one here, and take this 2. We've done addition of matrices. Let's look at the next concept. Let's look at multiplication of matrices. Let's look at multiplication of matrices. What's the condition for adding 2 or more matrices or subtracting them? What's the condition? That the dimension of what? The first matrix should equal to what there? Dimension of what? The second matrix. This same rule does not play for multiplication. Doesn't. Take down this. Take down. For two matrices to multiply, the number of columns of the first matrix must be equal to the number of rows of the second matrix. For 2 matrices to multiply, the number of columns of the first matrix must be equal to the number of rows of the second matrix. So the idea of saying they must be of the same dimension only works for addition and subtraction. When it comes to multiplication, the idea does what there? It changes. It changes. Example. So example is alright. Example, evaluate this. Example, evaluate this. Example, evaluate. Alright, so look at this. Look at this. How do I solve this? First of all, when it comes to addition, can they add up? Can they add? Huh? Yes or no? Can this add? Yes or no? No. Why? They're not of the same dimensions. But can they multiply? Let's see to that. Alright, so how do you know they can multiply? Simply get out the dimension. For this case, please, what's the dimension here? What's the dimension here? 2 by what? 3. Abi? Alright. So this multiplying, what's the dimension here? 3 by 1. So can this multiply? Yes. Why? We said the condition when it comes to multiplication of matrices is that the what? Column of the first matrix must be equal to what there? The row of the second matrix. So see my first matrix here. What's the row? This one here. What's the column? This one here. My second matrix. What's the row? This. What's the column? This. What do you observe? Observe that the column or the number of columns of the first matrix is equal to what there? Number of rows of what? Second matrix. 3, 3. For this case now, we can multiply. That's the condition. When it comes to multiplying matrices, the number of columns of the first matrix must be equal to number of rows of the second matrix. It's 3, 3. We can multiply. So how do you multiply? How do you multiply this? Note that when it comes to multiplying matrices, they work with the concept of row-column multiplication. Don't forget this. Row-column multiplication. What does that mean? It means use the row of the first matrix to multiply the column of the second matrix. So look at this. It goes this way. Row like this. Column multiplication. So I will use the row of the first matrix to multiply the column of the second matrix. How do I do that? I will take this row here to multiply this column. So this times this. So that becomes equal to this times this. 2 times 3 plus this times this. 2 times 1 plus this times this. 2 times 4. I have this. That's all. Please. Row column. 2 times 3 plus 2 times 1 plus 2 times 4, that's all. I'm done with this row and this column. Use the second row. Second row to this column. Repeat the same process. This times this, 1 times 3 plus this times this, 1 times 1 plus this times this, 1 times 4. Perhaps let me write this properly. Write this properly. Okay, so I have this. Alright, what on this is now equal to, I'm having 2 times 3, 6 plus 2 times 1, 2 plus 2 times 4, 8. 1 times 3, 3 plus 1 times 1 is 1 plus 1 times 4 is 4. I have this. So sum this up. It's now equal to 6 plus 2 is 8 plus 8 is 16. I'm having 16 into 3 plus 1. 4 plus 4 is 8. Now let me show something. Look up. I just said two matrices can only multiply if the column of if the number of columns of the first matrix is equal to number of rows of the second matrix. Now after multiplying, your answer or the dimension of the answer will be this one here. The two on the left. What do you have here? 2 2 by, what do you have there? It means that if I multiply a 2 by 3 matrix by a 3 by 1 matrix, at the end, my answer becomes what there? A 2 by 1 matrix. So look at this answer here. For this one here, what's the dimension here? 2 by 1. So 2 rows, 1 column. And that's what it's saying. So that's the concept. To get difference between multiplying and what? Adding. For adding, condition, they must be of the same dimension. For multiplying, condition, the number of columns of what? The first matrix is equal to what there? Number of rows of what? Second matrix. That's it. Example 2, please. On matrix multiplication, example 2. Alright, let's get this done. Tax 1. Look at what you have here, please. Look at what you have here, please. Look at what you have here, please. Can they multiply? Yes or no? Look at what you have there. Can they multiply? Yes or no? If I have two things, look up. If I have two things normally placed side by side and placed in a bracket, what does it mean? They are multiplying themselves. So you don't have to see times here before you do substitution. No. But they are placed side by side. It means they multiply. Look at this one, please. Do you think they can multiply? Yes or no? Huh? Yes or no? Yes. If they multiply, what will be the dimension of your answer? If they multiply, if you say yes, they can multiply, fine, no problem. If they multiply, what will be the dimension of your answer? Huh? 2 by 3. 2 by 2. Confirm that. What do you get? 2 by 3. Okay. 2 by 3. Alright, let's do this please. Case 1. There's dimension here. For this, what's the dimension? 1, 2. 1, 2, 3. That's a 2 by 3 matrix. Multiplying. For this, what's the dimension? 1, 2, 3. Have it? 3 by how many columns? 1, 2. So I have this. Can they multiply? Yes. Why? The number of columns of the first matrix is equal to what there? Number of rows of the second matrix. If they multiply, what will be the dimension of the answer? 2 by 2. This one here. A 2 by 2 matrix. Now let's do that. I have 1, 4, 5, 2, 3, minus 1 into 3, 1, 1, 6, 4, and 2. How does this multiply? You see, when it comes to multiply matrices, what am I using there? The row column idea. So use all the rows of the first matrix to multiply all the what? Column of what? The second matrix. Alright. So I'm taking this to what there? To this. Alright. So take the first row, multiply each of this. Take the second row, multiply each of this. That's all. First row to this. So what do I get there? I get what there? 1 times 3, 1 times 3, plus 4 times 1, 4 times 1, plus 5 times 1, 5 times 1. That's all. 5 times 1, 4. 5 times 4. That's all. Okay? So, I'm still left with the second column here. For the first one, it was just one column here. So, we did this and this and we stopped. But for this case now, after using this row, multiply this column, there is still a second column there. So hence, take this to this column. Let me take off this part here. So next up, I will take this now to the second column because of that 1 times 1 plus 4 times 6 plus 5 times 2. This into, so I've used this to multiply the first column, this to multiply second column. I'm done. Pick up the second row now, so this to multiply here and then here. So repeat the same process. 2 times 3 plus 3 times 1 plus minus 1 times 4. Okay. Take this to this now. 2 times 1 plus 3 times 6 plus minus 1 times 2. Alright. So it's now equal to, what do I get here? 1 times 3 is 3 plus 4 times 1 is 4 plus 5 times 4 is 20. 2 times 3 is 6 plus 3 times 1 is 3 plus minus 1 times 4 is minus 4. 1 times 1 is 1 plus 4 times 6 is 24 plus 5 times 2 is 10. 2 times 1 is 2 plus 3 times 6 is 18 plus minus 1 times 2 is minus 2. This is now finally equal to 3 plus 4, 7 plus 20, 27. So I have 27. 1 plus 24, 25 plus 10, 35. 6 plus 2 plus 3, 9. 9 plus minus is minus. 9 minus 4 is 5. 2 plus 18 is 20. Plus minus is minus. 20 minus 2 is 18. So I have 18. So you can see that at the end, my answer gives me what there? A 2 by 2 matrix as we predicted here. It's predicted here. This is how matrix multiplication works, right? Alright, copy down. Let's look at yet another concept in matrix. Copy down. So I'll give you the technique there. Right, first of all, check. Make sure that number of columns in first matrix equal to number of rows in second matrix. Then you now see the dimension of the answer there. Then you do your stuff. Take all the rows. Take the rows, the column, rows, the column. As you multiply them, you're adding. Multiply them, you're adding. Right? Let's do something else.